your shadows from my soul as these walls begin to fold. Head lost in the silence, cold stars illuminate the secrets on your tongue and the poison in my lungs. Where every passage ends, a new road begins. The further I descend in your labyrinth, blind eyes in the darkness, frail hands reaching out, sword echoes in the smoke as the doors behind me close. No cure for the madness, each turn tangled in the fear of losing sight of the slowly fading light.
There's no other way. Talk about a long night trip. No, no, no. Don't ever wait. You kept traces of my past.
What is going on, everybody? Happy Sunday. Today, I figured what we would do is try to fix the train wreck of the last stream. To reset, what we were trying to do is use my augmented reality headset and put some virtual content on the homebrew playfield. We ran into some issues with reading the controller. I was trying to figure that out. Didn't happen on stream, but the good news is that's been fixed now. So we are ready to go. I guess with that, let's go ahead and get back into it. So this is the scene that... Oh, let me switch. I'll get this one of these days. All right, so this is the scene that we had set up in Unity. Just to explain this a little bit, this red circle is the sphere is the marker that I use to tell me when the headset is tracking the image that I have on the playfield. Tracking that image and figuring out where that is in physical space is how I register the headset to the pinball table so that it'll place the content appropriately. Within the actual scene, we have this little animated skeleton guy that I got out of the asset store, and we still have this red cube in here that we just haven't taken out yet. This big black plane I've thrown in here because what that represents is the playfield plane. And this isn't strictly necessary, but the reason why it's thrown in here, anything that's drawn in black on the headset will end up being clear because the headset itself doesn't have a way of adding shadow. It can only add light. So effectively what this plane is going to do is anything that would dip under the playfield is going to be cold, so that we're not looking at content that would otherwise be beneath the playfield. Hopefully that makes sense. So let me go ahead and build this, which will launch it on the device. I mentioned this last time, just as a refresher. The bottom right-hand corner is going to be the device stream, where you're going to be able to see what I see through the headset. The use of the real camera, the RGB camera that's on the headset, you can't use that and the device stream at the same time, and I have to use that for the image tracking. So the unfortunate side effect is that I'm going to have to go over to the pinball table, hit the button on the controller, which is going to register the scene. Then I'll come back over here, start up the device stream, and then you can see what it is that we've done. So now that that is up, today's stream, by the way, is probably going to be a little short, but I wanted to go ahead and get this really going now that it's working. Okay, so you guys don't see this yet, but I see the playfield scene right here. And let me go over here and register it. Okay, now I can come back over here, turn on the device stream for you. Have to accept it in here. Okay, so now you're seeing what I'm seeing through the headset. Let me go ahead and switch this to bigger thing. Okay, so after all of that work last time, this is what we've got on the pinball table now. So you can see this is the image that we've used to register where the content sits on the playfield. There's our skeleton. There's the cube that's still sitting there, and you can notice that the cube doesn't look like it's protruding beneath the table, and that's why that black plane is in there. So, in fact, if I dip all the way down here, you can see the cube underneath the playfield because it's no longer being cold out. Also, for those interested, here's my homebrew electronic rat nest that currently works and is a potential fire hazard. So hopefully we'll make it through that. So anyway, now that that's actually working, I figured just for fun, we could try adding some terrain in here or something. Have I added that stuff yet? I have not. Oh. No, I have not. Okay. Let me get our asset store up. Nope, not the asset store. Asset manager. Package manager. I knew it was one of these things. Okay, let's do rocks and boulders. I went through the asset store, the Unity asset store. I'm not an artist by any means, so it's much easier and prettier if I go and just grab something. It's good that we have this cube in here because that shows me about where the end of the playfield is. What I could do is maybe throw down another plane and measure the dimensions directly so that it's 19 and 5/6 wide and however long. 46 inches, I think, is what I made my playfield. There's a little bit of wiggle room in the length. So once this imports, what we should be able to do is just kind of drop a few features here and there and make this look a little bit more like a scene. And it looks like we're done with that. Let's make this a little bigger. There we go. Okay, so rocks and boulders. Here are the prefabs of all these things. It's hard to tell. Wow, these are huge. Okay. Yeah, these are really big. Let's see if we can find something smaller. Yeah, this will work. Let's get a side view and move this down so that it's there we go. Okay. Oh, and we are going to want to put that under the playfield root because otherwise it's not going to move with what we want, or with once we register everything. Wow, these are really big. Let's scale this guy down, I guess. Let's try that. And hopefully what we'll be able to see is that it also isn't absolutely necessary that we stay within the confines of the playfield. That opens up some really interesting possibilities where we could have scene elements flying off of the playfield or coming in from behind you and landing down, or, you know, sky's the limit, really. You can do whatever. Scale this down a bit. I have no idea how this is actually going to look once it's in there, but we're going to find out together. Okay, so that should just about hug the outer bit of the playfield. We might get some theoretic collision here, but that's okay. Move you down into the playfield root as well, and we'll go ahead and hide that red cube. Just for fun, let's give this guy a couple of friends. I'm fairly certain that they're going to end up having the exact same animations, but that's okay. We'll make them synchronized swimmers / fighters. Okay, that looks good. So, in theory, that's all we got to do. Let's see if it works. Oh, while that's building, let me go ahead and kill the currently running process. There we go. So this is a command line utility that I can use to communicate with the headset to start, stop programs and things that are running. What I did wasn't strictly necessary, but I find that every once in a while the upload will fail, and it's much less likely to fail, at least in my perception, if I go ahead and kill it first. It's supposed to work, and it usually does, but just in case. We've got some time anyway. So this is the this is how I wanted the last stream to actually end. Was doing this, but it's all right. We're picking it up now. We'll get this going, and then the other thing that I want to try to do today is I have my driver board in there hooked up to my computer as well, and I'm getting serial output when buttons are pressed. So what I can do is I can take that serial output, I can send it over a network port to the headset, and then the headset can react to it. So I figured what would be fun is to see if we can put some particle effects on the slings on the playfield. Once again, though, we're going to have to write some code, so all bets are off. We'll have to see how it goes. All right, well, that's starting up. I need to kill the device stream. And I need to kill this again. This can't start. This can't start with the device stream on, because then the permission to get the camera hardware access gets denied at the beginning of the program, and then it's unusable. So I just launched it again via the command line. We'll see when it's up. Seems to be. And the camera's there. All right, let's do this. Acting appropriately. That's kind of cool. Okay, get you guys looking at it too. It puts up a prompt every time to make sure that you really want to do that. Okay. Here we are. Boy, these rocks are huge. But, you know, as you can see, we've got our three guys. At least now I know about the dimensions of the playfield. I'm not sure why that cube is still there. I thought I turned that off, but I guess we'll have to take a look. I feel like we could probably scale these guys down a little bit. I mean, I like the rocks. If we had more time and really wanted to get into it, and if I actually had something running on the playfield, something physical, then it might be worthwhile for us to actually place some of these objects. One of the things I was thinking about is that what we could do with the skeletons, for instance, is if we have lanes that have switches in the middle of them, we could place the skeletons where those switches physically reside, so that as the ball goes over the switch, you know, we could blow up the skeleton or knock them over or do something. And if you think a lot of the modes that you play in regular pinball machines that shoot these, you know, these 6 lanes, or shoot 4 loops or whatever, and with those rule sets, you could play your pinball table normally. But if you happen to want to play with a headset on, then you get pinball effects type visuals that are going on in addition to just the normal gameplay, which I think is a really interesting concept and would be pretty neat. So let me grab all of these guys, and let's... Now, what did I do? Let's scale them down a little bit. They were pretty big. And this cube... Okay, there. Now it's hidden. Alright, so... What's next? I guess I guess the next thing is, since that's working, let's go ahead and start putting in the interactivity. I want to go ahead and reflash the firmware while I'm sitting here, because I can't remember the last state that it was in. That's going to go ahead and build. Let me go to... Is that a little better? You guys can, yeah, you can sort of see what I'm doing. Let's see. Okay, we should be up. Let me just go ahead and build. One of the things that I've done in here is this is all, the driver board right now is an Arduino. So it's a AT Mega, but what I think I'm ultimately going to end up using are ESP32s, both of which you can program through the Arduino environment, but I really like the Visual Studio editor. So I wrote some platform code that will allow me to use the Arduino environment to populate IntelliSense completion inside of Visual Studio, so I can use that to code up everything and then launch it. So when I launch it, instead of launching a debugger, it launches this serial prompt that I put together that automatically connects, and this text here is what's being printed out by the firmware. So I just want to make sure and verify that pressing buttons still sends us the info that we want. Yeah, it looks like it. And to that end, I need to figure out which ones are the, it looks like 20 hex and 40 hex are the slingshots. Let me see. Okay, we are going to need to create a new standalone app that is able to forward all of the switch information that I'm getting off of the pinball table to the headset as it's running the program that we put together. Okay, let's go ahead and kill that and create a new project. I'm insane for trying to code live again, but it's what we're doing. Just do a console app. Put it in dev, just call this, I guess, pinball switch Marshall. All right, there we go. I'm gonna do this in C# just because it's easier. I actually really like C#. I like using C++ for very low-level things, like the firmware is written in C++, for instance. But for just doing one-off programs and stuff like that, I really like just using C#. So what do we need to do here? Quick and dirty, we need to open up the serial port. Call it serial port or COM port? COM port, must be. It's been a while, so no, they don't call it that either. Okay, well. Is it not in there? Oh, you know what? I'm using .NET Core. Okay, let's do that again. Rather than try to figure out where it sits in .NET Core, I'm just going to redo this and load it in the framework. I'm sure that COM ports exist somewhere in the .NET Core, but I don't know where they are because I haven't jumped into that yet. But no worries. glad that we figured that out first. Yeah, that'll work. Okay, so yeah, that's way better. Port. Nope, serial port. Yes, okay, there we go. New serial port. I happen to know that this is COM7 because I saw that. Baud rate is 115/200. Parity none. Data bits. Whoop. Oh, 8 data bits, 1 stop bit. And that's it. Open that up and let's see, how are we going to do this? Can I just read lines? Yeah, I can. We'll just do this infinitely. Granted, this is not a great way to actually code, but it's what we're doing because it's easy, and I'm doing it live. So, 9 equals. Okay. Okay. In theory, with that, we should be up and running. So. If we just run this, we can see whether or not we're picking up everything that the firmware is sending out. And we are. Okay, well, that's nice and easy. Okay, what was the... Did I copy that off? No, I didn't, of course. I forgot exactly what format I spit out that... I've got too much stuff open. That's the firmware. That's our program. Let's do this one more time. Oh, this is always going to start up on the wrong monitor. That's fun for you guys. Okay, S for switch, colon, and then I believe I'm printing out which ones change and which what state it's in. But we can look at the firmware and figure that out. Where is it? I just threw this in there. Okay, so the first one is switch change. The second one is switch state. All right. And for both of those, I'm printing those out in hex. So to parse this, let's just make sure that if line starts with S colon, then we'll assume that it's the right one, and then we'll do line equals substring, or line substring. We're still running. Let's kill it. I guess we'll just do this. Length, I mean 2 would have worked too. Okay, so that's now chopped off everything else. Let's do arch equals line split on a comma, and if arch.length equals 2. Let's see, we want to do int try parse and parts 0 number style. Can we do that without a format provider? Nope. Number styles, that hex number, no format provider, and out are changed. Okay, so now we should have state and whether or not we've got a button change. So the two buttons, well, here, Here, I guess real quick, let's see. I know that we need to look for 20 hex and 40 hex, but I don't know which is which. So 20 is the left, 40 is the right. Change and 20 equals 0. Actually, let's do this. Let's do left sling equals triggered equals changed and x20 not equals 0 and state and x20 is not equal 0. All right, and same thing for right, but we're looking for 40 hex. Okay, so now we know whether or not left and right slings are triggered. Just to verify, let's go ahead and print that out. Let's do it this way. Whoops. All right, give it another shot. One thing we're not doing, however, is debouncing these, so we might want to do that so that we're not sending a whole bunch of. That's left. That's right. Okay, so let me just make a debouncer class really quickly. Debounce, we're going to take an int of change and an int of state. We really only need 8 of these, but I'll go ahead and do 32 just because. Let's see, what are we going to do? Let's just store date time. This is way overkill for what it is that I'm putting together, but we'll, that's okay. Date time array of mlast change. And we'll do 32 of these. We'll go through all of these. Let's create a mask. Shift left eye. So now we can check each bit individually. So let's see, what do we want to do? We want to ignore state changes until they've been stable for X milliseconds, I guess. Let's see, that's actually going to be problematic if we're sitting there listening for this as well. Actually, no, that'll be okay. That'll be right. Oh, but we're going to have to apply them after that. Okay, we're going to have to change this read line to just pull data out of there. Anyway, all right. So, I've changed in mass does not equal 0. Okay, so if our button is changed, well, and we need a now. Last change equals now. Last change I equals now. Okay, so now we're storing off the last change we had. We need to return the current state. Balanced state. That will start at 0. So now that we've done this, if let me think about this for a second. So what do we want to do? If we are going to want to fill all of these date times with something. Again, this isn't the best way of doing this, but that's the way I'm doing it. We have a min value. Yeah, that'll work. Okay. So if in last change I equals date time min value, then just forget it. So we want to save off, yeah, we want to save off the last, actually it'll still be the same. Okay. Get the delta, which would be now minus the last change. If delta total milliseconds is greater than, say, 10, then we want to set debound state and equals not mask. Mask again. Oh, and in fact, we can just, yeah, let's just do all of this. Okay, so if we've been, let's see, if it's been more than 10 milliseconds since the last time we changed, then we want to remove the current bit in the debound state and set the new state bit. And then return the debound state. Okay. I think that'll work. Let's just do state equals debouncer, or debounce changed state. Here. Let's do it this way. We'll do raw state. We also need to return whether or not we've changed, because otherwise, yeah, we don't know when we triggered. Okay. Do this. And go ahead and set balanced state equals that. Debound state equals what it currently is. We need to save this so that we know what changed. So now we've got the new one. Debounced state equals that. Debounced change equals the new state. XOR with the last one. Now we know. Okay, so raw changed, raw state, and out in change, out in state, out bar. Yeah? No? What do you not like about that? You're not assign for. Oh, right. Okay, now let's see if this works. Nope, of course not. Okay, well, it's going to be hard for me to debug this from across the room, but let's see. Oh, we also want to set this to date and then min value again, so that we skip it. Okay, well, that didn't seem to be the problem before. Let me set this to 0. This should just always work. Okay, let's say that we set that to 0. Calculate our mask. If we have change, then we record the last change. If we've never changed, then skip the rest of this. Otherwise, we figure out how long it's been since we changed. If the total milliseconds is greater than 0 at the moment, because I just want to test this, then we set our debounce state. We remove the bit from that, and we OR in our new bit from our current state, and then remove the last change because we haven't changed again yet. So then we return the debounce state, and then the change from last time is whatever we just finished changing. Surprised that wasn't printing anything. Let's try it again. Well, all right, let's do this then. When in doubt, just print it out. Normally I'd be doing this with actual debugging, but since I have to be across the room, that's harder to do. All right, that's always setting that to 0. Why is that? We should be getting in there the first time. Let you guys see it again. Okay, yeah, so every time there's a change, it's remembering it. So it's setting it to now. Oh, is this because I have greater than? Nothing like some printf debugging on stream. Riveting, I'm sure. Okay, so that is actually working. Why is Oh, right, of course, because we're not actually updating it again. That's why. So that is still printing stuff out, but not down below. Or is it? No, that's this. The image is printing out. So, but if we update it again, let me just make sure that this is what the issue is. Right now, because we're sitting there waiting for a new line to come in from the serial port, we're not updating the bouncer again 10 milliseconds after we got a switch. So this should do nothing. But I'm holding it in, and now if I hit this other one, no, it still doesn't work. Well, what the hell? We're gonna fix this. We're not doing what we did last time. I have conviction this time. Okay. So how could that possibly be? Oh, well, again, that's still an issue. Okay, so instead of sitting here blocking for read line, what we're gonna do, again, this is a crappy way to do this, but we're gonna do it this way anyway. We're doing some quick and dirty code today on stream, ladies and gentlemen. What is the available bytes to read? Okay, while we still have more bytes to read, serial port, read byte. Let's see, so the character that we just got off of the serial port, if C is white space, do we have that? No. We'll just do this. If it's a new line, or I can't remember if we're getting line feeds, carriage returns rather, or line feeds off of the Arduino. Okay, so either of those is going to terminate our condition, which means we're going to want to go ahead, if SB length is greater than 0, then do some stuff. Otherwise, we're going to append that. All right, so this should give us okay, so now what we should do is we're going to be in this loop. I will go ahead and put in a thread sleep so that I don't have one. Again, sleep is not a good thing to program with, but we're doing it in this case. Okay, so the reason why I did that is instead of waiting for an entire line to come by before updating, we're going to pull out a line at a time if we can, break out of this while loop, and now we should have, if line does not equal null, then we've got some stuff to do, and then we are going to just update the deep bouncer. And to do that, we are basically just going to check in fact, we're just Doing the deep bounce again. Really, we just want to do this lower part, I think. Let me just copy this whole thing, and we'll snip the pieces out that we need. Don't need that. We do need to current state. Current state equals state. There we go. Okay. So we need that in there. This needs to be current state for whatever the last one. Okay, I'll just update. Do our mask. Skip that. If we're at minimum, figure out the delta. If the delta is greater than 10 millisecond, then we do that, and we set the last change again. And we output it. Okay, so up here, we don't want to do this stuff anymore. We want to just come in here and set current state and when the last change was that we got. So we'll remove that. Okay, so now every time that we get a new line, we're going to want to do this stuff. Sort of. We're going to want to parse it to there. Okay. Okay, so to recap. Oh, sorry. What software is this you were using, Surreal? Daddy. Hey, thanks for coming by the stream, by the way. Thank you. This is Visual Studio that I'm coding in. This is what I use for pretty much everything for the last 25 plus years or so. So I'm used to it, and it's hard to change. We fear change. Sorry if I was ignoring you. I got zoned and wasn't even looking at chat. So anyway, what was I thinking? It starts with this, does this, it gets the raw state. All right, so now the debounce. We're going to debounce with the raw change, raw state. Don't need this. Okay. So now what we've got is this is going to sit here and pull the serial port, pull out one line at a time, update the debounce, and now we can check for the debounce update. You know, really, if we were doing this, responsibly, all of this would be asynchronous, and we'd be reading this in separate threads and marshalling stuff. But I don't want to sit here and try to debug that on stream for sure. All right, let's see how we did. Got our sleep in there. Let's bring this back over. Okay. Well, that still didn't work. Let's just print the delta. Total milliseconds, okay. Okay, well, we had one that was updating. That's what we want. And now we set the last change back to min value. But but we didn't get a trigger again. That is curious. Let's print out the mask here. Okay, there must be a problem with our line parsing. So when we finally get a line, let's do that. Oops. Well, sorry, I didn't put that over on screen. That is actually working. So let's go back to our debounce. And print these guys out. I don't know why that wouldn't be working. That's quite odd. Quite odd indeed. This is genuine curiosity of what the hell. Let's print out the parts. Really wish I had my debugger right now. Okay. Now that's strange. And that's coming from this, right? Oops. Okay. Well, that's not it either. Let's debug it. Okay, so the parts are 1 and 1, as I would expect. Going to debounce. Put that out one more time. So you come in here. We're writing the mask. That's what it is. So we're setting hello mouse. My mouse dead? You've got to be kidding me. Oh, there it went. Very bizarre. Okay, so we're setting this to now. And at the end of this, our debounce state should still be 0. Our current state, okay, break, yeah. Now we want to come to update. Here I thought that this was going to go smoothly. Silly. Our debounce state is still 0. We're going to come in here. Our change is no longer minimum value. It'll be more than 10 milliseconds. We set our last change back to min nothing. Come back here. Our debounce state should be 1, which means our change is also going to be 1 now. Okay, because it's been the same for 10 milliseconds. I think my mouse is actually dying. Isn't that perfect? Unbelievable. Yeah, that's what's happening. Murphy's Law, am I right? Sigh. Okay, well, I guess let's let it charge just for a second. So, anybody know any good jokes? Me neither. Alright, let's see. Yeah, I think that that's exactly what it is, that my mouse has gone dead. Well, still getting used to the streaming thing, you know? And I learned another useful lesson today. Charge your stuff before you go live, because it'll go out on you. Alright. Well, I guess I'll call it. An hour is not very long, but, you know, if I don't have the equipment, there's not a whole lot I can do about it. Alright, well, next time, you know what? I was going to say next time we'll pick up where we left off. Let's not do that. Next time I'll have this ready to go, and we can just kind of go through it. And then maybe after that we can start talking about design or something that isn't going to catastrophically fail. So we'll get through it. We'll figure it out. Anyway, everybody who stopped by, thanks for stopping by. You know, I'm thinking that we're probably not going to have a whole lot more of these coding sessions. At least not until it starts getting actually interesting. So anyway, hopefully that's enough to get this going. All right. It's still... Let's try this. Something is interfering with my mouse hardcore. There we go. All right, we're back. Okay, well, thanks for another stream. Always very interesting stuff. Yeah, thanks for stopping by, Pin Daddy. I assume that you're the you're the one viewer that I've had for most of this time. I really appreciate it. You know, in the future, I'm going to try to iron this out a little bit more. But next time, let's see. What are we going to do? We're going to have debounced buttons so that they're not going nuts. And then I'll have the bridge ready to go, and we can start putting some animated something or others on the playfield. And maybe after that we can sit down and do a little bit of design work together. So, anyway, have a good Sunday, everybody. Talk to you soon, hopefully.